Hey guys, Eric Anielli again. Today I'm back. I got Mike, Indiana. It's a 1968 Volkswagen Beetle. The video we made, or I made at the beginning of it, we were going to relocate the fuel filter, and the kit did not work. It only works with a manual transaxle. So the video we're coming in back to where I got to the tune-up, and most importantly, wherever I broke out the scope. I don't have a dwell meter or anything to set the points. I use the filler gauge, but figuring out how to do it with the scope, it's very good. You ever wonder what 1968 points and condensers looks like on H scope? It's pretty cool, or any oscilloscope. It's a slow moving signal. It's a very cheap scope. It's packed with a lot of features, but any scope you got is going to get you, either of these, you're going to be able to measure dwell. All right, guys, let's just get right to it. If you don't like the nuts and bolts, I'm going to separate the chapter. Just jump to the scope. Just take a look at it. See what you think. And you guys that know about Volkswagens, if you ended up here, there's a couple, we think we got it right. I do. It's the only way it works, and he said it runs better this way, so we're going to go with that. But if you know about these things and you got any input on anything, please drop a comment. I know I'll appreciate it, and so will Mike. All right, guys, let's get right to it. So you can see where the sun hits it. It's never the same color wherever you look. You stand at a different angle, and then if you look at the other side of the car in the shade, it all looks the same color. That's an awesome paint job. But what we do have is the tune-up kit for it with some new wires, new cap, rotor. We have points and the plugs. All right, guys, moving on to the tune-up. I just hooked up the HS512 and H scope, and I'm using like a rot key. It's C1, a secondary ignition pickup. It's very small. Just clamps around the wire. Now this is going around the coil wire. So we're going to get like all four, and I'm going to see if I could fit them on one screen in scope mode, like a parade pattern. And then, just record it on automotive module. See, I'll just snap the throttle. So it looks like, saved on there before and after. This would be 4 cylinders. If you're missing that idle, you're definitely going to see it there. But, you're not going to miss until you're on a snap. We're not going to have enough time for all that on one screen. That's a good signal, though. Keep that on 100 milliseconds duration. Hit record. There we go. Same thing. I'm going to switch the screen recorder and do a couple snaps. Guys, this was just one channel. I was just doing the secondary. Just take a quick look at it. You see the before, you have something to compare it to after the tune-up. It's not misfiring. They all look pretty good. And you see a couple things like that. You just want to check make sure it's not repeating. And then after you tune it up, you could go back and look, make sure you don't see too much at, because that I wouldn't be alarmed. It still has a lean uptick on it. It's either turbulence. If it did repeat, like 1, 2, 3, 4, 1, this would be the same cylinder. It's firing beautifully. But if you've seen that same turbulence, that same in every one, you might want to take a look inside that cylinder or look at your valve, something like that, the way it's breathing. But this is going back. you're only getting one. I mean, this is happening very fast. So every now and again, the point that we're capturing, is mid-explosion, but just make sure it goes back to this. All right, guys, I'm moving from the points on, and there's a couple videos out there. People take the distributor off, work at it on the bench, but I mean, come on, guys, the cars we work on, this is like a picnic. I got the condenser screw out the back. Mike said, don't worry about changing that. If it was hard, it looked like a hard place to get to, but aren't they all? But I didn't want to leave anything on there. Do see some rust on it, but the wire looked good. And basically, I went with the new one based on it. It's green. I like the green. So I'm going to get that out of there. Some of the best tools I like using for that, like these little guys, these are Dorman. They're pliers. They're not snippers. They're good for pulling little things like that without breaking them. And this is just their, bigger brother. Plus, you get to say Knipex or Nipex, however you say it. And this would be, I mean, you could look at it one way. It would be simpler without the cap and the wires on it, but there's so much room here. I mean, I'm not complaining about this, but you would get a little bit more, if you disconnected something. But I'm just going straight in it because we go right up here to the coil. And that's what I'm going to pull off. And see, it's a good thing. I mean, it's coming off pretty good, but I'll clean that up a little bit for them, just a little bit of sandpaper. It's your routine maintenance. Just like your old truck. All right, I use this and this little ratchet just to loosen this. It's a straight screw right there, and you don't want to lose these. You either want to pick this up all together. I'm still plugged in right here, though, to the condenser, and bring it up as a unit where I have these Harbor Freight magnets are actually stuck to the back of the wrench right now, but I have one in the finger of my glove. And so even when I pick up on it, it's not coming with it by itself. But I'm going to be more confident when I pick up these points like that. See, that wire's still connected. If I didn't have the camera, I'd just pop that while I'm holding. I'm not even really grabbing the points. And I'm still holding that in there pretty secure. But I'm going to put the camera down, just grab the pliers and pop it right off the condenser. And then right into a magnetic tray. I don't piss around, guys. All right, guys, I don't know a lot about VW distributors. I mean, what you would consider excessive or how tight these are, brand new, or what condition. But one thing with the internet, I know if you do know something about these, the first thing you'd be doing is turning this shaft, seeing how much play was in it this way and this way. And you could see it moves quite a bit this way. Let me zoom in. That way, and then back and forth. Enhance. There you go. That's how much we're getting back and forth. Now, if you guys know anything, any more than this runs pretty good right now, drop a comment. I'm sure Mike will appreciate it. Next, I'm going to just take a little bit of brake clean. I'm not spraying it into the distributor. You don't want to do that. I'm just going to spray a little bit on cloth, and then I have a couple swabs. This one clean up this is pretty clean. Just, get around, clean up all the grease. Now, one thing, this didn't come with point grease. But I got some synthetic wheel bearing grease. That's what we're going to use for the time being. Easy enough to change out. And also we're going to put a couple drops oil right down on that filter. All right, guys, that's enough junk to have made it worth getting out of there. So that's cleaning off the shaft and all around the sides of it. Now I'm going to put some of that synthetic bearing grease around. Would be talking about this lower part here, right where it's going to make contacts with the plastic part of the points. One thing about points and condensers, they don't like moisture. I just put a little bit of dielectric grease around this part going into the distributor, and it's literally just a touch like that, Just a little dab. I didn't even open it. And I'm going to put that over the coil connection too. Just that much is all you need. You don't want to pack this. It's an insulator. It's not a conductor, but it will help, you know. Anybody that ever rode a motorcycle with points and condensers, you know it misses like hell until you shake off that morning dew. All right, I got Aaron to hold the camera because I need two hands to adjust the points. What you do is you put this rubber block up against the highest point. There's 4 lobes, 4 points on the distributor shaft. And when it's open, you take a filler gauge. This is 16 thousandths. And you loosen this screw just enough that you could move it without it springing back. You can see 2 little tabs up in here. This is for a flathead screwdriver to move this gap forward or backward. And you put the filler gauge, and it's still going to be hard to see. That's why a tripod was impossible. Put the gauge in between the points, and you keep loosening them until you feel just a little drag. Oh, you old guys will know that right away. As soon as you hit that, it's almost like a brake caliper with the slide pins. It's smooth as butter, but you still feel a tiny drag. Then you tighten down the main screw. This is working a little bit better for me. Yeah, stubby screwdriver, anything like this. Now that's enough to hold it there, and you make sure you still feel that drag. What I'm going to do is turn the engine by hand and just check it on a couple of the other points of the shaft. Make sure they're all even. All right. All right, on Slade's channel with the distributor, he recommended putting a couple drops of oil right down the center of the shaft. So 1, 2, 3. And so we're going to leave it at that. If I didn't watch that video, I'd have definitely never did that. So, good job. All right, guys, I got both the spark plugs out of the passenger side. After I got the wires over there, I'm just moving out from the distributor cap. The plugs that came out of it, this is 27 thousandths. I don't have a 27, so what you do is you just add 2 together. This is a 13 and a 14. You're not going to get any closer, to bend your stack. So these are perfectly straight, and that gap's good. Tiny bit of play in it, but it's pretty good. The plugs don't look horrible. It's firing. Some of these VWs, they puff smoke, so they burn a little bit of oil, and those are pretty clean for a VW. It's not misfiring. The whole thing was just it was kept in very good condition, kept in the garage, but it just hasn't been tuned up in years. So we're just out there driving it around. We're getting it going a little bit better. But this is the new Bosch, and they do not fit. They're gapped too tight. So I re-gapped the other one over there, but I'll just show you how to re-gap these. If you, cool trick or a good way to do it and be 100% on. All right, guys, shine a little bit more light on the subject. These Dorman pliers I showed you before in the distributor, what I do is just take them and grab a little piece of this electrode. But before I even do, wait for the bike. All right. But as you can see, these electrodes are not perfectly straight. When you bend them, you're going to think you bend them, but look at the tops of these. That's the way they come. That's the way a plug comes anymore. They're not dead on square. So don't look at it and say bending it this way is what made it not square, because trust me, this does not. And I just bend it back a tiny bit. And that's going to be more, I hope. I go a little over. That's what I intend to do. Exactly. I'm not trying to get it in there. I just want a tiny bit more. But as you can see, that would be too big of a gap. There's too much wiggle room. And then, I mean, actually I have it right here. I thought I was going to have to go get it, but I use it on the other one. You take the spark plug and just put it in one of these spark plug, I wouldn't call it a gapping tool, but a gapping assistant. No, a gapping tool, yeah, but you're the one still doing the manual gap here. You put the 27 thousandths in it, and you turn this screw, and what that's going to do, before I turn it, let me give you a better view, is instead of me bending that back down with pliers, this is going to put even force straight on that ground strap. So you don't have to bend back and forth. When you have to take a couple cracks, bending that back and forth, you're weakening it, I guarantee you. Just put them in the gap like that. This one's pretty close already. Right when it feels like a little too tight, because when you back it off, it's going to give a bit. And when you got it right, you can't wiggle. That will bend before you feel any slop. But look, smooth as glass. That's what you want, that little bit of drag. Guys, this is a cheap Amazon one. I can't even remember the name of it, but it's built pretty good. It's like billet aluminum, and I've gapped them every way. I mean, I've been doing this for 35 years, man, and the tighten the gap on them, measuring them using the round, not using filler gauges on them, using the round plug gappers. I mean, that's all. I've done all that, man. I mean, and this is still, I mean, this is, you will get every gap exactly. And then guys, on an air-cooled engine, copper anti-seize, any kind of anti-seize really, but the copper, it's going to take a little bit more heat. You're going to make sure you don't hit the electrode. I'll just kind of hold this, so just part of it hits it like a paintbrush, and you don't have to go the whole way around. You're going to twist this into the head. I'm trying to show you, I don't know if I could get it in the camera here, but there's where the spark plug goes through, and you want to make really sure that you don't strip anything. You can't see the hole in the head. So, you can probably see the hole in my head when I put this in, but, oh, I'm sorry. You can feel it touch. You don't want to drag that tip through anything. Like, don't try to fill around with that ground strap, because you're going to pick up some oil. Try to go right for the hole, and I mean, you could feel real light pressure, and you don't want to cross thread this. If that was an insert on the first one, you know, that's how it happened, I guarantee you. I'm going to finger tight there. I'm going to look up the torque specs, and we're actually going to put the torque on them to what, you know, VW wanted. That one there, you know, there was a sleeve on it, so yeah, I'm tightening 2 threads at once. I tightened it to where it just felt, you know, good and solid. If that is the repair, it was done right. All right, and the spec is 22 to 29. So we're going to go in the middle. We're going to go for 25. I'm going to grab a 3/8 torque wrench. Okay, guys, I got the 3/8 in there. I took this wobbler and spinner off. Whenever I torque something with an extension, there's locking. You know, they come with a spark plug set. They lock onto the spark plug. And I don't like wobblers or swivels whenever you're getting a torque, because you're going to, you know, lose a lot of torque with a swivel, so you have to overcompensate a little bit. And I'd rather just have a good solid connection like that. I'm going to tighten that till we get to 25. And make sure you stay centered on it. We got to be getting pretty close there. We're not moving much. go. Double tap it. Truthfully, guys, that's a pretty long ratchet, and as long as I've been, turning bolts, I would have guessed that was 40 foot-pounds, but that's 25 foot-pounds. So, that's why you always use a wrench. Even guessing, I would have thought that was over-torqued, and then we would have had an under-torqued plug. This kind of extension is what I switched to. It's a straighter, no give. This is a wobbler, not very good for torquing. On this side, guys, it looks like that's the most inaccessible, but I have a shorter 3/8 flex head on there. And right in between the wire and that hose, you got to give it the classic South Main Auto Airco reach around and bust it loose, and it comes right out. And you could use anything. You could use the spinner at this point. I'm just, got the ratchet there, showed you where I had it. I just keep it in my hand. It basically is like using that spinner till it's almost finger tight. That's a little one I use to get it out. I don't know how good the torque wrench is going to get back there, but, give it a try anyways. But remembering back whenever we looked at these as being hard compared to what else was on the road, we also got a lot more things that wobble and wiggle today. Yep, the rotor's different. Turned the key, I was wondering why it didn't start. This does fit in there. I mean, it makes a pretty positive connection, but you could see the height difference. I matched the caps up. The caps are the same size. Kind of odd the rotor isn't. But I'm going to clean up the old one for right now. Make sure it runs and goes. I mean, anybody my age that's, worked on a lot of non-computerized engines, you've seen distributors that belonged in other engines, in engines a lot. And I mean, these were a common engine to swap distributors on and parts. But one thing we got into is this is a auto stick shift. It's an automatic, but it's a stick, so you got no clutch automatic. It has a different distributor than most, so we know this probably isn't a distributor out of a bus. But the thing that was odd is this cap is the same as the part number. Now this is almost like the shell game here. This is a cap, the tall cap. This is the rotor that was on it. It's a shorter rotor. Now, the new cap, same exact cap, but the rotor, look how much taller the rotor is. And you're like, what the hell? Something's wrong here. And to make matters a little bit more confusing, some of the parts that came with the car, there's a shorter cap. So just going by common sense, you'd think the shorter cap with the shorter rotor, the taller cap with the taller rotor. So even though we were starting to get to something on this end, I wanted to do a little more research on it. And what we did find out, we found the right distributor. This is the correct cap. This is the correct rotor. But when it came in, it had that cap and this rotor, and it still ran fine. But one of the things doing the research is Volkswagen used a cap like this with a rotor like this. And this cap couldn't take the higher output coil. So what they did was made this taller cap, which they still used a shorter rotor, which caused more crossfire issues inside the cap. So as far as I could figure, because we looked at I'm going to show you again I'm going to show you on the tablet here. Now this, I could assume, fixed the crossfire issue, but they both work inside that cap. So what you would have had, I mean, yes, the the spark would have had to be jumping this much further inside that cap. And that's what it was, that's the way it ran in with it, that the tall cap and the short rotor. So maybe they will get a little bit more, you know, performance out of just a basic tune-up, because like I said, the points and the plugs weren't, you know, all that bad. But now we got it sorted out, we're gonna, you know, see if it runs now. All right, guys, this is the part number 113905-205T and later. Not this one here, that's this. This would be with the vacuum and the centrifugal advance. 71 and later Beetle and bus. This is a 68, but it also says a 68 through 70 Beetle and bus equipped with automatic stick shift options. So that's us all day long there. The cap's right cap, correct breaker points, and the rotor is the taller rotor, not the one that came in with, but this is the taller one. So I'm hoping that that's, you know, for the crossfire issue, they made an improvement. So, you know, maybe get a little bit of a performance gain out of it, just, you know, getting an updated part in there. And you know this is the point where, I mean, if you're one of them Volkswagen guys, you know exactly what this is, and you're laughing at me. But I'm laughing at myself, actually. But this one, after just saying that and looking online, finding its exact distributor, this still doesn't, I mean, look how wobbly that is. And how much slot. That's not even turning the gear. Turning it that far. When I'm pressing this, I don't know if you can see from there, but you see the cam block for the points. This isn't making the whole way, this is hitting the cam block. It's not going down the whole way on the shaft. And I mean, if you could see that, the wiggle in it. I mean, it's catching the gear, but look how far that's turning. This is the one that was on it when it came in. Nice solid contact, no slop at all between the shaft and the rotor, and you can't have no slop in that. So even according to that, even with the auto stick, this is still the short distributor, or the short rotor. Now should it have the small cap on it too? It came in with the tall cap exactly like this. Makes me want to put the short cap on it just to see what happens. I think that's what I'm going to try, because there's no contact issue. This fits on there. You're right as rain right there. Oh, right there. It's, I mean, you can tell there's no, the button's making contact with the rotor, but it's not excessive. I mean, that's kind of what we want right there. See, that's it, just the same amount of button movement. So, and on a, you know, a better note, a lot of people to clean up the engine bays and have a better looking engine bay, you know, they prefer the shorter cap. And I'll tell you one thing, it would be a much better route for the coil wire, because it's on a sharp incline. Oh, let me show you where that's at. Like right here, there's where the coil wire goes, right there. And there's where the top of the cap wire is. So it's a very sharp bend, and the taller cap only makes that bend sharper. So this is an old cap that came with the car, but we're going to just see if it runs any better with it. And it still wouldn't start, but whenever I go back now, I'm backtracking as I go with just going to ground with a test light. I'm getting power coming out of the coil. I'm getting power on the clip here. Now on the other end of that clip, it's just this simple, small, short wire. You see that wire? Let's see if I get some more light on it. Just that wire right there. On this end of the clip, the white lights. That's why I took them back out. I wanted to touch the other end of that wire. Nothing. That's actually going into touching the other end of this copper wire. I mean, what the hell? That's crazy. But what I'm going to do is just put the old points in, do the same thing, see if I'm getting power up to the points. There's no power going to the points. There's power going to the points while it's flowing through the coil towards ground into the distributor itself. But the other end of that black wire, the points have nothing on them. Zero. What was odd is I didn't even have to pump the gas, but that might have been from it not running yesterday. The gas wasn't pumped today. I was starting to beep from outside and warming up. Alright guys, pretty easy to see why that this wasn't making contact. There's no solder or any place where there ever was solder on the end of this wire. So the only thing that was making contact, and even testing it yesterday before I gave up, the test light I was getting going to battery ground, it was lighting the whole way on this clip, but the points were, it wouldn't light with the points. So that led me to, I mean, we're gonna have a problem in this short wire. I doubt it. You know, I figured it was one of the ends, and sure enough, you couldn't see it while it's on there. You had to pull it out and take a good look at it. But I'm gonna scuff it up and put some solder on it. Rather have them leave it some new points anyways. Alright guys, being I'm getting out the soldering iron, I'm going to just show you a couple tips in case you don't know. And this is just the gas. I really like this I wrote. Gets very hot and it's very short. You can control the heat. It doesn't matter what kind you use. I haven't used this in, a couple weeks, so this is just like a chore boy, something to scrub dishes with. I got it crammed in the container. You don't so much want to twist. I stick it in and just drag it out. Once you get it warmed up, get all that junk off of it. And then once you could see it, you could take it to a sponge or wet rag or whatever you want. But what I do is just take that straight out of there while it's still hot, hit it with the tip tinner. And then set it down till you're ready to go. It comes in little, I mean, this is a couple dollars on Amazon. And it's always going to get you in the right direction with your tip. You never want to hit them with sandpaper or anything to get the junk off. It's not enhancing very well, but I mean, you can see it looks better whenever we started. And then whatever you're going to hit, I want to keep this on, but I mean, like I said, that will get very hot. That's on low. I'm going to take a little bit of just bottled flux, and I hit it with some sandpaper, and right where you're going to solder, just make sure you get flux on there. You can't use too much, so don't really worry. You could use too little, but not too much. And then, yes, this is Radio Shack and solder, and no, you can't have any. Just put a little on the tip, and it's going to just hang there like a drop. Then just take it and touch it to with your solder and let it get hot. Look right there. I'm going to just add a little more on the tip. Let's get a hot melt it in, and you could see when it goes flat. Unless you got a good solder joint. I could shut that off. And it cools pretty quick in there. Then you could see, hopefully it's going to focus in here for us. Enhance. Oh, let me get the light. You see how flat that solder joint went, and the whole wire is now encapsulated in solder. That's kind of what it was supposed to be, but they did not. See, there's the loose end of the wire. It's soldered to the copper now. Now we should have, you know, electricity going through this and back into the points, because it was never making it to the points. It's a pretty crappy connection. But we'll see if that solved it. Sure should have. All right, after the repair, yesterday this is what was happening. Like on the negative of the coil, going to ground, we're getting power. Coming into the distributor, we're getting power, and this was the same as yesterday. But when I go over to the points, now it's lighting up. Yesterday it was stopping. Right here would not light up, but right here did. So we knew it had to be in this wire before I called it quits, this wire to this wire. So, you know, now we're getting power to that. So I know, you know, without a doubt, this is going to start again, because that wasn't happening. I put the old points in just to get it running, took a better look at that and seen it was something that, you know, a little bit of solder would fix. So going to put it back together and fire it up. Probably put on the scope again. It's going to be interesting to see if we could see a difference between this and a longer cap route. But I think most of it's going to be like, you know, test drive, just seeing which one, if this one does cause crossfire, because from what I heard, with the higher output ignition, or what I read online anyway, the higher output ignition, they were having crossfire issues with the shorter cap. Now this is just a regular, you know, it's not high output coil, it's a stock coil. It's not the original, but it's, you know, it's not a performance brand or anything like that. So it's, you know, we're going to assume it's stock, not a high output. So the shorty should be, you know, our ticket. Here's one thing we didn't like, guys, that the condenser wire, or the wire that goes into the points, how long it is. Did like the green color, but, you know, the black wire was just as long, but, you know, the black kind of blends in better. So what I'm going to do is cut off the zip tie. There it is. Let's see about how long we want this wire. I'll leave a little bit of slack. I'm going to just cut it right where I'm holding it. Just a little more exposed, not too much. Then we're going to take one of these. Put it on there. I'm using these double crimp connectors. Resistance, the insulation side. So line them up in the crimpers. It's going to crimp it to the insulation and the wire, so you get a double crimp out of it. It's very good factory style crimp. As you can see, it got the wire and it's attached to the sheathing. And then we're going to just move this up. Then we got a better, shorter path to the coil, that's all. tidy up the engine compartment just a little bit, especially with this shorter coil, because you do see more of the back side of the engine, or what's behind the distributor anyways. Yeah, everything does seem much better with the shorter cap, because I mean, you could unloosen this bracket, move the coil up, but if it was never moved or that was where it was, you get a much shorter coil wire with the wires that went with the taller rotor. So it makes more sense that this shorter wire goes to the shorter coil. The other one, with the longer wire, it was just at such a weird angle. You had to bend it like a double S just to get it from the cap to the coil, because you're up above. You're almost even with where you got to put the plug. So I'm going to fire it up and see if this is it. I'm going to just hit the gas once back here and go and turn the key, and hopefully the points make some noise. Something's not right there, guys. I got a shot. That's got to be a wire or plugged on the loose. Yeah, guys, this is odd. This is that wire I was just speaking about a second ago, the shorter wire. Whenever I was checking the wire again, this thing slid back out. I buried it in here, but you could just see just the vibrations of the engine's going to keep pulling this wire out. I mean, it's kind of crazy. We had a issue with almost every single component, and these are all Bosch. So, in order to not get shocked, we're going to either put the old, see how they come right out of them? I mean, I should have probably popped this part off, but that just slid out. It was already metal showing, and I pushed it in there as hard as I could. So what I could either do is expand these to stay in there a little bit better, but I'm still not sure I trust that. It's this S-bend. See, here's where it has to go. See the end of the coil right there? That black piece right underneath the green wire? It has to plug onto there, and it's coming right over to here. It's almost a straight line where you could use, like, you know, one of them angled boots, but let me see what we could do here. All right, guys, getting a shock whenever I gave it some throttle. That was a little bit odd, but, you know, the wire slid right out of the coil, that short wire. This is the old coil wire for the tall cap, but I took that wire off and I put just a hex bit, put it in the end like that, and it expanded it. Gave it a little bit twist like that, and then took it out, popped it in there, and it's in there, you know, rock tight now. You can't, it's not going to slide out for sure. It didn't move at all. So I'm going to keep that in there, but you know, there's always that possibility you might need, that might be why there's a longer wire on it, or it was for the taller cap. But altogether, you know, got a pretty good running Beetle right now. All right, guys, I took out the oscilloscope, the HS512, and I'm using 8 scope, and I'm going to show you what I got set up. I figured, well, it's here, and trying to find the differences between this cap and the taller cap. Get a, you know, once again, get a secondary ignition, and then I wanted to see if I could see a coil ramp on coil and amperage. So what I did is I have my AES wave. I have it, that's a low amp clamp. I have it on 20 amp scale. And then I'm using Rotkey secondary. That's C1 secondary pickup, HS512, and just Samsung tablet. I'm going to put this on tripod and put the fan on so you could see, then maybe go to screen recorder. But what I want to see is a couple snap throttles, what's it doing, and then see if we could compare it to what it was before with the old plugs, and we'll be able to compare it with the taller cap. Technically, guys, I mean, the taller cap we could put on, but to me, it just seems like it's going to have more of an air gap, but you know, maybe we're going to be able to see it. All right, guys, I am choosing the coil wire to put this pickup on for the main reason that we could actually measure the point dwell, or the dwell time of the coil, but we're going to want to see all four compared to just seeing one cylinder. All right, let's give it a yank, fire this mother up. Gonna let it warm up for a second here. Then I'm going to switch over to the screen recorder. Now we know we're getting a signal. All four popping. You could get all four on the screen. We don't know which is which, but this is just oscilloscope mode. Okay guys, I shut that off for a second just because I want you to hear me. That sound that these VWs make, it sounds almost like a misfire, you know, that little rumble with engine. It, you know, basically makes them sound like a VW. The biggest thing I always attributed that to is the muffler. Mike was thinking maybe it's a misfire or something going on with the ignition, but we should be able to see this. This is all four cylinders. This is just oscilloscope mode, so we're watching this live. If something's happening whenever you hear that classic VW stutter, we should be able to see it, which waveform's doing what. Now I'm going to start it again and jump right back in. Here's something. Alright, I like that just on oscilloscope mode we could get all four. If we had 6 cylinders, we might have been in a little trouble. But looking at the spark lines, I mean the burn line, you can measure each one to make sure each cylinder is burning properly. But the big kicker is this lean uptick. They all got a very lean uptick. They all have plenty of oscillations. Some people count these oscillations. As long as I see a couple, I'm happy. Same with these ones. That means that coil's still got some power. It's not running its max. Now the dwell time, there might be a way to do it without RPM, but usually we need some way. On a newer car we could use the crankshaft position sensor, but on this car we can't. We can measure dwell time. A lot of these cars were in dwell angle. We could measure the time. That would be from here to here. Like if we wanted to measure that, all we got to do, I'm sorry, I'm on a towel. The mouse doesn't work quite well, but we could measure the time from here. This is where the coil's starting to charge. It's getting saturated. That's here. What we see in the secondary. With two cursors down, we can measure over how long that was, and in milliseconds, get 10.02 milliseconds. So we can measure the dwell time, but the dwell angle would have to we could use the degree rulers and just assume between two firing events, or between the next firing event of the same cylinder, there's 720 degrees of crankshaft rotation. So you could get down to the dwell angle. Might give that a shot, but this is the dwell time. That's what you'd be looking at. That's a good thing to take note, especially if you're changing something in the ignition, to see what's right and see what you're doing. This is mainly your point gap here. But if you're going to make a change, you're going to want to see, does the taller cap affect how long the spark's burning? We don't see an extra gap. You're not going to unless there's a very big one, like on a tall cap and a short rotor, which, you know, I think might have been happening. We're going to take a look though on the old one. I can't get the current ramp back on it, but I did save the secondary ignition. Okay, now guys, I'm just rolling over into the automotive module. And I'm going to make sure everything stayed the same. My probe's still a ×1, and I still have the AES wave, the 20 amp clamp on. So that's good, that's correct. To hit record, I'm going to hit the button on the amp clamp to zero it, and I'm going to zero it on H-scope. This is the button. Should be zeroed. Hit it. Alright, I'm going to fire it up. See, down here we're getting a signal. There you go, guys. If you hit this eyeball, it takes you, that's what I mean sometimes, but it doesn't seem to make your pattern bigger. If you enlarge it just by pinching and zooming, then you got a little bit more control. And this, I might not want the coil ramp that big, so I'll shrink that down. Then we could move that up closer together. Take a look at different parts. Like on the snap, what'd it do? How did it do? This guy's honestly through the snaps. This is a snap throttle right in here. Looking at these burn lines and the spark lines, the firing lines and the spark lines themselves, I really like what I see. I mean, you're going to see some differences in turbulence like this, but you're on a high demand. That's where you're getting at. And I really like seeing oscillations left here and here. So all in all, I mean, that's a good sign. I like that. Guys, when you're dealing with something from the 60s, sometimes you get some handwritten notes, but this is what I'm going off of. As John Muir says, dwell is half the number of degrees the crankshaft turns while the points are closed. Half of 100 degrees is 50, so the dwell is 50 degrees for the Volkswagen. On an 8-cylinder scale, a meter will read 25 degrees, but the real dwell is 50 degrees. So, okay, we have a sketch here, but the main thing we're going to use for the oscilloscope is dwell is half the number of degrees the crankshaft turns while the points are closed. So that's what we want to know. That's our key takeaway here. To our waveform, what I'm going to do now is drop the degree rulers. And I'm going to make sure they're on 360, because the degrees we're going after with this formula, it's not about the camshafts, it's about the crankshaft. But it's going to be easy to line up because we know two firing events. Oh, let me hold you still for a minute. There's going to be two firing events in 360 degrees. So if we line 360, and this is where I'm sure you can do it with 720 with a little bit of different mathematics, possibly a math channel. But I'm going to get that as close as I can. I'm lining it up with the end of the dwell. So what we're going to measure is in between here. Now this is where a math channel, something else might help you a little bit more. But this way, because your RPMs aren't going to be right with just one, with 360. But 360 is what we're after. We're not using the 720, and then we're dropping actually removing this. I gotta remember I did this. I did this once, guys. But now what I'm going to do is on a piece of paper. Now this is where a math channel, or there might be another way, but you know, this is how I did it. You're right there at 92.3 degrees. That's when dwell's beginning. It's ending right on 179. Okay, so 179 minus 92.3 gives us 86.7 between one dwell right here and right here. Now divide that by 2 and we get 43.35. The spec for a VW dwell is 48 to 50. So you could see what my next step is. The car ran better leaving, and we could tell just by looking at this on the scope a day after it's gone that the next step to make us run even better, or to even try, that's what the fun part is. I mean, is you're making an adjustment and you're seeing a difference on a tablet, on something that has no OBD port and has points and condensers. So you're going to be able to accurately get this degree right. So looking at it, the dwell is the time that the points are closed. I would want to increase this time. So I would want to take some of the gap out of the points. They're over gapped even though they're at the factory spec of 18 thousandths. I mean, it's right on with a slight drag. I mean, that's dead on 18 thousandths, I guarantee you. But what this gives us a look that they couldn't have had back then. They had dwell meters, but you know, I don't keep one around anymore. I keep a scope around. So in the occasion that you do get a points of condenser, don't be afraid to use the scope. I mean, I like it. Well, we have a lot of other measurements we could take, but what's really, when you look at idle, and you look at the bottom of this screen where my pointer is, do you see how this line dips and then goes up and then dips? Where it dips is more demand. That's where I'm snapping it, and it's increasing the RPM. The coil, the firing line, gets lower because there's more demand on the coil. So it's very easy to move this to where the engine was being snapped. And look at the lines. When there was demand on it, look how low these lines are. When these lines are low, that's your most strain on it, which is your snap throttle. And you could follow it to where it goes back up again. That's where you snap the pedal. Right here. And then anything on this side is your D cell. The firing lines are going back up. There's no demand on the pedal, and we see some of them. There's a couple lean upticks, but you see a couple rich uptick, or no lean uptick to them, which is common on a D cell. But what I see a lot is lean, even under demand, lean upticks. That's usually a beautiful line. That's what you're looking for. If you have an engine that's not doing this, that's when you start to have a little concern about a stuck open injector or something like that. But I'm not saying anything yet that it means anything, but I mean, just what you see on the spark is you see lean. That there's not, on all the waveform that I've gone over, everything is lean. Even under the snaps, you see a couple rich ones, but everything's lean. So that gives you a little insight into the engine that, you know, it's hard to get if you're just guessing it, but you could see for sure if this burn line went down, it would be rich. Instead of this lean uptick, it would be aimed down, and that would be very, you know, rich. We're not seeing many of them. It's pretty cool playing around with it. And what you could also do is, even while you're, how much current does a VW coil draw? 2.55 amps. So it's not a very high drawing current or coil. And we could tell this coil has a lot of oscillations left behind it. So does the spark line. So that's a healthy coil. That's a healthy spark. But what I would like to do next time we get the vehicle in here is actually increase this dwell. Make the gap a little bit smaller than the factory. See if we could hold this open to get, you know, 48 to 50 degrees. All right, also, if you're on something this old, a lot of times you try different plugs, or you could also see the difference. And I mean, one of the easiest things to do with ignition is measure that burn line, how long that spark's staying lit inside the cylinder. And you could draw two cursors and go right to the middle of that lean uptick right there. We have 1.06 milliseconds right here. I mean, that's a good healthy spark even for a fuel injected engine. So, but if you make any changes in your plug gap, like if I would have put the ones in, the gap was narrower, this should have been a little bit lower. So you could play around with, like, you know, if you're doing custom things too, you're not always looking for something that is a problem. you could do this, you know, if you're trying a different set of plugs, if you're trying a different brand, you know, if you already got a baseline like this of what it looks like with Bosch's, you know, whenever you change, check them, check the spark, check the firing line, check your spark line. Make sure you got the oscillations, and then make sure the coil's not being stressed. Now this is the one coil fires all four. Whenever you're doing a coil over plug, I mean, each one of these is going to be in a different coil. So if you see one weak ramp, you're going to get different numbers. And here, this is all the same coil, and it's firing beautifully. Just a couple other things you can measure on a car that has no computer to talk back to you. You know, two non-invasives. We didn't back probe anything. Both of them were just, you know, clamped over a wire. All right, guys, that was the first time using the scope on this car and on like a point system like that, and, you know, figuring out the dwell. It could be, you know, I'm going off of somebody else's way of doing it and incorporating it with an oscilloscope, and, you know, instead of actual degrees on, he was talking of like, you know, like a degree, torque to degree using the actual flywheel. But, you know, the scope's a little more accurate than that. We could see we do need to make an adjustment there, close the points up, let Mike drive it around for a while, see if that improves it. I mean, yeah, one more horsepower out of these things is a lot. You know, they don't have a lot, but I mean, there's so many other things we could do to it. There's so many other things Mike wants to do to it. He wants adjust the valves. I mean, that's a very simple process that's right there in your face. You're on a creeper, but it's not hard. We're going to do that, and what would really be cool to use the in-cylinder transducer before and after, see if we could see any valve action with the scope. You know, it doesn't matter what kind of engine it is for that. See if we could get some accurate compression out of it, use a manual gauge and a pressure transducer. A lot of things we're going to be using the scope on this car for. Not to mention the charging test I never did. This was a pretty quick, you know, tune it up, and then we ran into a little bit of, you know, ordeal with the cap and the points not being, you know, conductive, to put it that way. But I mean, I might have had time to do a couple things like that, but this car's going to be back, and if you guys are interested in that, stick around. In the meantime, thanks a lot for watching, guys. I appreciate it. Adios. Now I'm going to let you watch Mike roll it down the alley. He lives right at the bottom. All right, guys. Adios again. Good.